Okay. All right. This is lesson 1-7, day 7 of unit 2. Sorry, 2-7. And this is sign regression. So I'm going to teach you something new today. We're going to use it to apply some of our trig knowledge, but we're also going to use it as an opportunity to get to know our calculators and to also incorporate some calculus ideas, but using our calculator to help us find them. But, just to start talking about some calculus ideas. And also see, I don't know, some kind of real world applications of what we're doing. So, this is the note sheet. It might have been on the back of this sheet, or I don't know. Just depends. It's available in some different places. You want a graphing calculator today. So, regressions are when we fit functions to statistics, and we kind of try and create a formula, an equation that will model those. So there's things called linear regressions, quadratic regressions, sine regressions is what we're going to be using today. So lots of different ways, depending on the type of behavior you see, it might be more appropriate to use one or another. So on your calculator, we're going to go to the stat menu. So we're going to use some statistics stuff here. And if you've taken statistics or AP statistics, maybe some of this is familiar to you. So the stat button brings you this menu. And what we want to do first is enter some numbers, some data. So we're going to go to number 1, edit. So that's all listed right here, stat. And then we're going to go to option 1, edit. Hit enter. And it brings up some lists. Now, there might be some numbers in here from some previous, problem that someone else did or you did in some other class. So you could just get rid of them if you want. Now, you got to be careful because you could actually delete the whole list. There is a way. I'm trying to think. I think there are some quick ways. If you go to the bottom, let's see. If you go to the top and you hit clear, that'll clear it real quick. But if you go to the top and you hit delete, so maybe you have a whole list, like, I'm going to go to the top and delete them all at once. That works, but now your list 1 is gone. Oh, man. So how do we get it back? So be careful. You can clear the list if you needed. You could select the name of the list and then hit clear, and that'll work. But if you hit delete, that's bad because you lose the whole list. Okay. So the way there's another way to clear the list too. I'll show you in a second, but we can get our list back, okay, by going to the stat button again and going to number 5, setup editor, because you might want to get it back, and hit enter. So let's see what happens when we do that. Let's try and see if we can get our list 1 back. So we go to stat number 5, setup editor, hit enter, go back to stat list, edit. Hey, it's back. In fact, it has all the values in it still. So that's the way you do that to get it back. The other way you could clear list is you go to stat and then you could go to number 4, clear list, and you could tell it which list you want to clear. Now, if you want to enter a specific list, you can go, you'll see these L on my calculator, see L1, L2, L3, 4, 5, 6. Those are lists. So you could do second list 1 and actually put the list 1 there, and it will clear just the list 1. So now if we go back to stat, edit, list 1 is now cleared. So there's some different ways to do it. So like I said, you could go to stat. I mean, so there's a number of ways to do this. And you could go option number 4, clear list, and then type in L1 and then hit enter. And that will clear it also. Okay, but let's actually enter some values in here. Let's put these in L1, L2. It doesn't. So these are going to be times of day, the time of the day, and this is going to be the temperature, okay, for our little example. So we're going to do 1, 4, 10, 14, 20, 22. Now, I could have said 1 a.m., 4 a.m., 10 a.m., 2 p.m., 8 p.m., and 10 p.m. And a lot of times that might be the way that the information is given to you. But when you enter it into your calculator, we need to enter it as 24-hour time. Otherwise, it's going to mess it up. It's not going to be able to tell the difference between AM and PM. And it's going to treat them the same. And it's going to mess up your curve. These are the temperatures: 42, 47, 54, 71, 63, 58. Now, if you were to ever look at a graph of the temperatures over the course of a day, guess what? It's going to look very much like a sine cosine curve. It's going to look very, very much like a trig curve. So it kind of happens a lot of natural phenomenon that we get these sine curves. That you look at, waves in the ocean. If you just look at the tide height, if you tons of things. Okay, so we're going to enter these in. So we got to enter them as 24-hour time. If you don't, you're going to get the wrong answers. So you got to be careful sometimes. So 1, 4, 10, 14, 20, 22. Now double, triple check them. If you mess one of these up, it's going to mess up all your answers, or forget one. 42, 47, 54, 71, 63, 58. Now double, triple check these, okay? One of these wrongs and mess everything up. So everything's going to rely on this. So we got those in. So that's how you put them in. So that's the first thing you've learned how to do. Now we're going to figure out how to create a regression curve. Now the cool thing is the calculator is going to do it for you. So all you need to understand is the idea. It's kind of like a line of best fit, and maybe you've thought of that in even algebra 1 or something. But instead of a line of best fit, we're going to do a curve. We're doing a curve of best fit. Okay, and depending on the kind of numbers you're getting, certain kinds of curves would be better. Now, this is a very probably kind of trig wave. So if you go to stat and then you go over to calc, okay, and you go down here, you'll see linreg. That's a linear regression. It fits a line to it. No matter what, it'll fit a line to whatever. Even if the stuff doesn't really look like a line, it'll fit a line to it. Quadratic, that's a parabola. Cubic, quartic. Another linreg, just a different version of it. Natural log reg. So some things are kind of natural log graphs. Exponential reg. We definitely have things in real life that are exponential. Power reg. So that'd be kind of like a polynomial. Logistic, which is another type of growth that's a little more realistic. And then last but not least, sine reg. That's the one we're going to use. So we're going to use sine reg. Option C. So we're going to do option C, sine reg, which is appropriate for our trig chapter. We're going to hit enter. Okay. After we select it, it's also at the bottom. So the quickest way to get to this, if you're to go back through here, is to go up from the top of the graphic, the top of the list, and you get to the bottom left right away. So we hit enter. Now it brings up sine reg on here. So it brings you to what we call the home screen. So I was just adding some notes for you for reference. You might write these down too. Now, if the information is in list 1 and list 2, that's going to be really convenient. Okay, we refer to those as the default lists, and that's what your calculator will assume if you don't tell it what list. If we just hit enter, It's thinking, and there it is. There's your sign regression. Now that's going to be based off of list 1, list 2. Now, if it's not in list 1, list 2, then you need to tell it which lists. Now, if it is list 1, list 2, you can tell it. Now, the way you do it is you select list 1, list 2. You get put a comma between them. So you say second L1, comma, second L2. Now, if you don't put those, that's what sign reg is going to do. It's going to pick L1, L2. But if it's any of the lists, you got to tell it which lists. And the order matters. So you hit enter. It's going to give us the same answer it gave us before. Now, so the way to, if it's in another list, you have to type in the list, like L sub 2, comma L sub 3, and then hit enter. And then the way you get those lists is by doing second. The number 1 button gives you L1. The number 2 button gives you L2. The number 3 button gives you L3. Number 4 button gives you L4, and so on. Okay? So that's how you do that. Now, after you get this, I want you to write all this down, which is the most tedious part of this. Sign reg. I want you to write the whole thing down. First of all, it tells you what the equation is. It's giving you a sine curve that has a bunch of things happening to it. It has a vertical shift, has a horizontal shift, has a period change, and it has an amplitude change. So this will give you any kind of sine curve, but it's going to fit one to your numbers. It's going to shift it up, down, change the period, change the amplitude to fit it the best way. Now, the values of these coefficients are then given to you below it, and I want you to write all these numbers down. Because if you mess this up, guess what I'm going to do on your test? I'm going to type these in and see if your answers are right and only dock you off some points. Now, some of you guys' calculators, if you use other TIs or other brands, these might be a little bit off. And that's another reason you want to write these down, okay? So that I can check your answers, even if you did it correctly. I'll know what different brands give me for questions I'm going to give you on tests, okay? But my answers on homework and stuff are going to be based off this TI 83. So I want you to write that down on your homework and box it, okay? That's going to tell me if you did all the first stuff right. Now, after that, if you got this wrong, you can still get the other stuff right. So what we're going to do now is we want to graph it because we want to do some like calculus on it. And so what we could do is we could go in and type this equation in with all these numbers in the right places into our Y menu. It sounds horrible. So guess what? There's a shortcut, and you're going to want this shortcut, okay? So the way you do it is we're going to go to the Y menu, okay? And we're going to go to vars, which is something we've been using as shortcuts before. And we usually get, then we usually go over to Y bars, but we're not going to go over to Y bars this time. We're going to go to number 5, statistics, which makes sense because that's what we're dealing with right now, statistics. So if you go to statistics, then you're going to go over to equation because we just came up with this equation from statistics, and then we're going to pick option 1, regression equation. So after you've created the regression equation, it's stored in the memory, and this will access the last regression equation that was calculated. Okay, and then you're going to hit enter. So if you do that, look, it just pasted that. It pasted this into the Y menu with all the numbers in the right spots. In fact, it's showing more accuracy of numbers. Just imagine having to type all that in. And now it's done for you. So you definitely want to use that. Okay? So that's a nice little trick. Now we're going to graph this. Now, before you ever graph anything, we haven't been graphing for a little while since last chapter, but we always go to window first. Okay? Always go to window. And if you have any idea what the window should be, then you should enter it. Now, since we're talking about hours in a day, we should probably say 0 to 24 for the X. Now, I don't really know what the Y values are going to be. You could kind of guess here. You can be like, oh, the biggest one's 71, so I'm going to put 71 here. Well, not necessarily. When it fits a curve, it might fit a curve that goes might go over 71, and the lowest value might not be 42. Now, I kind of like seeing the x-axis anyway, so I might say 0 for the min, or even -1. And for the max, yeah, maybe 80 would be good. The other way you can do it is you could do zoom fit. Okay, so you could do this. Oh, now if you get something that looks very flat, something went wrong. The good news is you don't have to really redo anything. Right now, we need to be, for these problems, because now we're doing, has to be in radian mode. Okay, so we have to be in radian mode for these problems. Okay, it's assuming radian mode. Otherwise, you're doing degrees right now, and it doesn't look right. So go back to mode, go to radian, and guess what? Everything is perfect. The regression equation is correct. Don't have to do anything. Just go back and hit the graph button, and you should get something that looks a lot more like a sine cosine curve. Okay. Now the other way you could do it is you could go to window, put 0 to 24, and then you could go zoom fit, which is the last option, zoom 0, and it pre-calculates the y values and fits the y value so it fits the graph perfectly, which is cool. But you know what? Honestly, I kind of like, and you could go back to window and see what the window was, but I really do kind of like seeing the x-axis, and I like to go at least a little bigger than the highest point. Just it's easier to work with. So, I mean, but that is a cool trick. If you have no clue how big the graph's going to be, you could do zoom fit. It does backfire if your graph gets really big, because then it gives you a huge looking graph that might be hard to see important stuff on. So let's write some little notes down here. We're going to go to window, always go to window, and we're going to say x min is 0 and x max is 24, because this is a word problem and we're dealing with hours in a day. So that makes sense. If we're doing days of the year, I'd say 0 to 365. Then you could go to zoom, and you could do that option I just told you, zoom fit, okay, which is option 0. And what that does is it calcs the y's to go with your x's. So it does depend on you putting in appropriate x's from your window. Okay. You got to do that first. And then it adjusts the y min and y max to fit it perfectly. Anyways, it's cool. Now, so let's see. So we're going to display now here's a cool thing that we're not going to usually do, but I'm going to just do this time just to kind of help you understand what we're doing here. We can actually display our statistics numbers on here, and they're not going to fit this graph perfectly. The way you do this, and usually I'm not going to do this because it potentially causes a problem, go to stat plot, go second y equals stat plot, turn the first one on, or hit enter on it, turn it on. You can decide what kind of statistics graph you want. We're going to do a scatter plot, which is the first one, which is pretty common. And then you want to pick list 1, list 2 if that's where your data is. And then you can pick these little squares or pluses. I'm going to pick the little open squares. And then I'm going to go and graph it. And so you see all those, it graphs all the little, those are the numbers you entered in that table. And there's that curve trying to fit it, which is kind of cool. You can see how well it fits it, but it's not perfect. There's errors in measurements and things like that. So let's go ahead and draw. So you need to be in radians, by the way. If your graph looks really flat, it doesn't look very curvy like a sine curve, then you're probably in degree mode. Just change the radians, regraph it, you should be good. Okay? Now, let's draw a sketch of what we have right now. And just a rough sketch. And this is time. This is temperature. This is 24 hours. This is 0. Okay, we can even put the little square things here. We never need to do little squares again in my class. I just thought it was a cool thing to show you. Okay, So honestly, let's go and turn that off right now, because what's going to happen is if we delete the list one, list two, and don't turn off that that stat plot, it's going to cause an error anytime you try and graph anything. So anytime you try and graph something and you get an error, one of the first things you should probably do is go to stat plot, and if any of these are turned on, turn them off, because that causes problems. So now if I regraph it, it graphs it without the little scatter plot. Okay, so so we go to so the stat plot, that's something that was just for fun, but let's not do that in the future. But if you do use this calculator for a statistics class, or you borrow from a friend that uses it for statistics class, this could be an issue. So turn them off when you're not using them, at least. Okay, now we could, so I'm going to ask you guys some questions like, when was the temperature at least this much, or what was the lowest temperature, what's the highest temperature? So we can do all this stuff that we've done some stuff like this in the last chapter. We go second trace, calculate maximum. I want the maximum between 0 and 24, and it looks like it's around 15. I'm just guessing because that's 0 to 24. And it's actually at 16. That's the time, and that's the max temperature, right? So, I mean, we could even say, all right, the max temperature is 16.004581, comma 69.330086. And now the way I'd answer that question, I'd say the maximum temperature is 69.330 degrees, whatever, Celsius, Fahrenheit, at times 16.004 hours, or 4 p.m. or something. But I don't need you to change things back to minutes and stuff. I mean, that's not that difficult. We could find the minimum temperature. Second, calculate minimum. 0 to 24. It looks like it's around maybe 3 a.m. or 2. It's at 2.746 hours, and the minimum temperature is 42.782. Anyways, anything you find, go ahead and write it on your graph. This is just good. Just makes it easy if, in the future you got to use it for something else. And I put extra decimals just because you got to calculate it. Anyways, on the homework, so the homework is on a separate sheet. What I'm giving you is 4 sign regression problems. So they're a bit of, it takes a bit of work to enter the information and get the equation and paste it. I'm only giving you 4. What you might want to do is store each equation in y1, y2, y3, y4, and turn them off, so that if you get stuck on anything here, that you still have the equation and you don't have to redo it, like tomorrow when we go over the homework or something like that. Okay, so why don't we go ahead and start the first one together? All right, let's go and just start the first one together. Let's see if we can enter the information. Now, this first one's a little hard because it's the days of the year. Now, I'm giving the days of the year, but that's going to be hard to answer some equations. Find the hours of daylight on July 4th. Now, one way to do July 4th is to be like, well, it's between here, and if June 19th is the 170th day, well, how many days are in June? Add that to 19, figure out the difference, and then add 4 to that, and then you can figure out what July 4th is. Otherwise, you could, I don't know, I always forget that trick of like using your knuckles or to figure out how many days are in each month. In January, there's 31. In February, there's 28, unless it's a leap year. Let's go ahead and just assume it's a regular year. And now we're at a total of 59 days. January, February, March, there's 31 days. So at the end of March, we're at day 90. No, not 90. Day 90. March, April, there's 30 days. May, there's 31. June, there's 30. July, there's 31. August, there's 31. September, there's 30. October, there's 31. November, there's 30. December, there is 31. So at the end of April, we're at day 120. At the end of May, we're at day 151. The end of June, we're at day 181, which means July 4th would be day 185, right? It'd be 185. See that? End of July, we're at 212. At the end of August, we're at 243. The end of September, we're at 273. The end of October, we're at 304. At the end of November, we're at 334. And the end of December, we're at 365. Perfect. Anyways, you can use that to help you. I'm not going to make you do that kind of stuff on a test, but I don't know. It's good practice right now. Okay, so we got to enter this information in. So we're going to go to Y, now what you could do, like I said, is if you're like, well, I created all this, I did all this work, I don't want to have to redo the list or redo this. You go to the equal sign and you hit enter and it turns it off. And then you can go down here and put your next one here and keep this one turned off while that one's on. And you get a bunch in here and turn them all off except for one at a time to do work with. Okay. So now I'm going to go to stat, edit, and I'm going to get rid of this information. So the quick way is to go to the list name and hit clear. Don't hit delete though, and then hit enter. That's the quick way. Otherwise you're going to lose your list if you do delete. Or you can just delete each entry. So we need to do 79, 170, 262, 353, 365. And then hours of daylight, 12, 14.5, 12, 9.5, and 10. Double, triple check these, because if one of these is off a tiny bit, it's going to throw off all your answers. So just make sure these are all correct. Okay, so then we're going to go to stat. We're going to go to calc, go up from the top to get to the bottom list, sign reg. If they're in list 1, list 2, you can just hit enter. And then it's going to calculate. Now, I want you to write this down, all of it. You don't have to show a lot of work on these problems, okay? So we're going to go and write these down. Write this down. Okay, write everything down that they gave you. And this will help you figure out why your answers are all off. And it'll help me figure out how to give you partial credit on a test, because I'm going to have to retype these in. And even these values are stored more accuracy inside your calculator. But I need to type in as much as I can to get my answers to be as close to yours as possible to give you full credit for most of the stuff that you did. So just write all this down. It's a little tedious. Just carefully write it all down. Okay, so this is the first thing you got to do. Okay, now let's graph it. We go to y equals. You go down here, go to vars, number 5 statistics. Go over to equations, reg equation, number 1. It pastes it in there. Go to window. Now we're dealing with days of year, so it's going to be 0 to 365. Y min can be -1. Hours of daylight. Well, 24 is for sure the most hours of daylight. And you might be, oh, there's never 20. Well, I took a cruise to Alaska a couple years ago in June, and it felt like it never got dark. But according to this, I don't know, maybe 16 will be the most or something. We could always adjust it, or you could do zoom fit. So graph it. Should look like a nice curve. If it looks all flat, you're in degree mode. Change it to radians, regraph it. You don't need to redo anything else. So there's that. Now I want to sketch at this somewhere. Just a sketch somewhere. Okay? Just a sketch. 365. And if your sketch is wrong, then that'll also tip me off that something's off. Okay? So I got a little sketch. And then it says find the hours of daylight on July 4th. So we figured out that that's day 185. Now, there's two ways to do this. You could go on here, second calc trace value, type in 185, and it tells you right there that, so you could do second trace calculate number one value, right? And then you put in x equals 185 and you hit enter. I'm just writing these down for you if you want these as a reference. If you remember, we get 14.452685. So the answer is 14.452 hours. Those are the units. Or you could do 14.453 if you want to round. I personally stay away from rounding as long as possible. The other way is to go to the table. You guys remember how to do that? Second graph button takes you to the table. And this is pretty convenient for just calculating values from a function. So if you go second table, there's some values in here from some old problem. So I'm going to just get rid of those. And you put in 185. Boom, there it is. Highlight it, you get more accuracy down here. Okay? So, yeah, that's the way you could do that. Now, okay, you got to watch out. Now, if you turned off Y1, it won't show up in your table. But if you turn it back on, Y1 will be here and Y2. You got to know which graph you're using. Okay, find the days on which the hours of daylight is between 10 and 12. That feels really awkward the way that's written. Between 10 and 12. Now, here's the trick. What I would do is I'd graph the horizontal lines for 10 hours and 12 hours. 10 and 12. Add them to my graph. Look, that's 10, that's 12. I'm going to kind of make it extra clear. This is between, probably not including then. This is the chunks of the graph we're looking for. These are intervals, right? And so we got to find the intersections. Now, if you want to make sure, it's kind of a little iffy here what's going on here. So we could change our window to make it fit a little better. Like we could say y min is at like 8 and y max is at like 15, just so we can see it a little better, which is sometimes helpful to me. So that's the 10 hours and that's the 12 hours. So, add this stuff to your picture. If that's your strategy, show me. And then we say, we'll calculate intersect. Now, first curve is the sine curve, and the second curve is this curve. And then you want to guess. You say, well, that looks like it's around, like, I don't know, 10 days or something. So I'm going to write this intersection here, 22.689587, comma 10. And then I'm going to find second calculate, number 5 intersect, first curve, second curve, and then over here around 300. This should give me this one, 317.5661, comma 10. And then I got to find these other ones up here, second calculate, number 5 intersect. First curve is the sine curve. The second curve I want to be the Y4 curve. Oops. The 12 one, right? And then guess, you could find this one first since we're close to it if you want. 260.80048, comma 12. And then second calculate, number 5 intersect. First curve is the trig curve. And then we want that curve. And then we're going to guess around, I don't know, 50. 79.455918, comma 12. So I'm writing all this stuff. Write all this stuff on your little sketch. Now the answer is right in front of you. That's why I want you to write all this stuff, because that's it. You don't need to tell me what buttons you're pushing or whatever. The answer is parentheses 22.689, comma 79.455 union 260.800, comma 317.566, And there's got to be units. These are days. Okay, now you could have rounded some of these. I guess if you're really into rounding, this would be 22.690, and this would be 79.456, and this would be 260.800 still, and this would be 317.567. So that's an okay answer also. But you got to put the units. Okay, guarantee on your. I'm going to give you guys a problem like this on your next test. Okay, total hours of daylight in a year. Well, imagine that each of these, you could graph each day. The value of the graph is how many hours of daylight are in that day. So if we go through and we find all the hours of daylight for every day, 365 days, and add them all up, they give you total hours of daylight in a year. Now that's a lot of work. So an easier way to do that is it's actually going to equal the area under this graph. Do you guys know how to find the area under that graph? Second, calculate. Number 7, integrate. Now I want you to show me. So we're trying to accumulate all the hours of the year, and that's what integration does. It accumulates. Okay? So it's the area under the curve. Okay, now I need to see the setup. The setup is 0 to 365 of your function. Now, we'll just call that f of x dx. And this is good enough. Now, I don't want you to write that whole thing, but you can just write, this is good. Now, if I do this, I type in 0 to 365, make sure it's on the sine curve, and it's going to shade it in. You could do this from the home screen if you want. And it should give us the answer. 4391.278 hours of daylight total in the year. Boom. Got it. Okay. So we're going to do a little integration. Find the average hours of daylight from days 50 to 51. Well, how do you find the average of a bunch of stuff? Well, you figure out what the total is, and you divide by the number of days or students or whatever it is. But this is also using an idea that I brought up at the end of last chapter on the extra credit review. I said, well, the way we find the average of any curve is we find the area underneath it, flatten it out, because that is F average right there, that average height of the curve. But then the area under the curve from 50 to 150 is still going to be the same area, but now it's a rectangle. And if you divide by the base of the rectangle, which is going to be the difference in the x limits, okay, it gives you the height of the rectangle. This is how we find the average function of any function. It's called the mean value theorem. But it also makes sense that you would find the total hours of daylight from 50 to 150 this way, and you would divide by the number of days, which would be 100 days, right? So now we could calculate that on here. We could do second calculate number 7, and we could say 50 to 150. Now we can't see the shading. You can clear the drawing, by the way. But it gives you 1277.819. Now I'm a little bothered that I can't write more than 3 decimal accuracy, because who knows if that's rounded or not. And if I want to divide this by some weird number, I'd have to go back in and type it on the home screen, 1277.18 divided by 100. So I would probably be more tempted. So the answer is going to be 12.778 rounded or truncated hours per day, average hours per day of sunlight. But I'd probably want to just do math 9 vars y vars function y2, by the way, is the one we're using right now, comma x comma 50 comma 150, and calculate the integral this way, which is probably faster. Gives you more accuracy on the display, and it stores even more accuracy behind the display, divided by 100, and then I don't have to retype it either, and I get a better answer. I mean, it's pretty close to what we got, but I feel a little more secure about it. Now, from that graph screen, let's try it again, because sometimes you can calculate something on the graph screen, and then from here, if I say, well, I want to divide that by 100, if I hit divided by, oh, that totally worked that time. So sometimes you can do math on the answer you got from the graph screen, and it'll take you to the home screen and use that answer, but sometimes it doesn't. So it's not always dependable. So that's how we could do that. And then number 5 says find the rate at which the hours of daylight are changing on the first day of school this year. Now, this is probably inaccurate for this day, but this was one of the days in recent history. So let's just go with this. August 22nd. What day of the year is August 22nd? Well, at the end of July, we're at day 212. And so if we add 22 to that, we're at day 234. That's my little trick. So we're at day 234. The rate is the derivative. It's the slope of your curve. That's telling you how much the hours are changing as the days change. So you could do that from the graph menu, and you could go second calculate number 6, dy dx derivative, and then you could say, well, I want a day 234, and it shows a little blinking dot, and it shows you right here dy dx equals negative 0.0392852. Now your answer needs to have the right units. All these answers have units, hours or days. This is a rate, so this is hours over days. Okay, change in hours over change in days. So the answer is going to be negative, because we're losing hours per day, 0.39 hours per day, or hours/day. Okay, now you could change that if you're like, oh, that's hard to figure out. This is totally fine, but we could change it to minutes. We could say, all right, well, what if we wanted to change it to minutes? We'd multiply it times 60, and see, it doesn't let me do that. Negative 0.0392852 times 60 would give you negative 2.357 minutes per day, which might be a little more meaningful than 0.039 hours per day. So we're losing a couple minutes a day in August, late August, which makes sense. The longest day of the year is in June, right? Which would be the max of our graph. So there's a couple ways to do that. You could also do that from the home screen, which might be more convenient. We could do math 8 in derive, vars, y vars function y2, comma x, comma 234. And we get the same answer, but now we can more easily do math with it. So that's one of the convenient things. The answer is also calculated a little quicker. So you could go to, so this is the slope of the graph, the derivative of the graph. So you could go to second trace, calculate, and then pick option 6, dy dx, and then hit x equals 234 on the graph and hit enter. So that's one way to do it. But you could also go on the home screen to the math menu and pick option 8 in derive, and then it'll bring that up on the home screen, and then you could go like vars, y vars, function, and then pick y2 in this scenario. And then that would put that right here, and then you do x, and then you put 234 that way. So that would work. Anyways, also down here, just some notes. Remember to always change your window. We said x min should be 0 and x max should be 365 because we're dealing with the days in a year. Y min for sure can't be less than 0 hours of daylight, and Y max for sure can't be more than 24 hours of daylight. So that could be a good first window. And then you could do zoom fit or whatever. Anyways, You guys try these other ones. We're definitely there's a couple questions on here like number 8. Maybe you don't have, you could think about it. See, you've tried. I'm going to teach you guys a little more. Number 8, number 12, and number 15 are a little involve something that we haven't talked about. So we'll talk about that tomorrow. But try all the rest, get them all set up, get your sign regressions, store them in the calculator. Don't delete them so that you can go back and answer any questions that you got stuck on or didn't finish, and so you don't have to redo all of that. But anyways, just an interesting application using Trig to some real world problems.